Hey, D-Dax, you're here with another great math video for you. This one is on target with graphing polynomials from zeros. All right, so what are zeros and what do they have to do with graphing a polynomial? Well, they make it they make it a lot easier to graph. So if you've got functions like x cubed minus 5x squared plus 8x minus 4, some of us, we just might go, well, I could find the y-intercept. If I just put in zeros for all the x, I know it's going to go to -4, but the rest of it, I'm not really sure. I have another video that I put out earlier. It's about end behavior and what are the general concepts of the graphs. If you're going to sketch a graph, what does it basically look like? But I want to go through that a little bit with this, but also give you some ideas of how to get the zeros of the function and then draw or sketch the graph. All right, so let's look at some basic information. All right, the zeros, what are the zeros? The zeros are of a function are the values, okay, of the variable x, typically x value, where the curve, so the curve of the function, crosses the x-axis. So when we say the zeros, we're really looking at what are the values of x where the function crosses the x-axis. We could also call these x-intercepts. We've called them roots of the function, and this is really when y equals 0. Okay? So when x equals 0, that's when we're dealing with what crosses the y-axis. Okay? But when y is 0, we're bringing everything down, and we just want to know where that function crosses the x-axis. Okay, so we look at example number 1, and synthetic division. So if you remember synthetic division, we basically draw our little bucket here. We bring the values, the coefficients down, -5 plus 8, -4. And then we often will do the PQ test, which is where we try and find the factors of 4. And so the factors of 4 would be P over Q. We get plus or minus 1, plus or minus 2, and plus or minus 4, right? So we try one of those, and if we're successful, we get a 0 at the end, then we can factor it the rest of the way. So if we try we're starting with example 2. If we try number 1, right, just the first letter, the first number, and we get 1 out here, then we bring the 1 down, we go 1. 1 times 1 is 1, and we add these two together, so that becomes -4. 1 times -4 is -4, and we add those two together. 8 minus 4 is 4, and we get 1 times 4 is +4. And that gives us a 0 at the end, and so now we know that 1, or x equal 1, is one of our zeros. So we put a little mark there. Okay? Then we have 1 times -4 times 4. We can factor that. And we ask ourselves what two numbers multiply to +4 and add to -4. And we find out that we get x minus 2 and x minus 2. Excuse me. X minus 2. All right? And so when we do that, we notice that, oh, look, we've got a situation where the function at 2, right, has a multiplicity of 2, right? Because we can rewrite this as x minus 2 by the power of 2. So when we go to graph this function now, we'll know that if I did the y-intercept, that's at -4. So the graph will come up and it will bounce off, come up through here, -4. It will come up through 1, and then it's going to turn, and then it's going to go like this, and so it'll end up graphing something like that. Okay, hopefully you can see that. That graph looks like that. Okay, so it'll come up, cross through 1, because x minus 1 is the first factor. And then when we get to these, this has a multiplicity of 2, which means it bounces. Again, you can watch that video that talks about the multiplicity and find about that information. And once that bounces, we know that that function goes here. All right, let's look at another example. This one is a factor by grouping example. So when we factor by grouping, remember that we basically take the first two and then the last two terms, and we factor something out. So in this case, I'm looking at factoring out an x squared, and I'm left with an x minus 4. And in the other two terms, what's in common is a negative 9, so I get a negative 9. And then that leaves us an x minus a 4, which is good because we really want these two to match, right? Because then we factor that out. So we have x squared minus 9 as a factor, and then we have x minus 4. And so this one, however, we know we could reduce that further. That's a binomial square. So that's x plus 3 and x minus 3. And then we have x minus 4. Okay, so here are my zeros. And what we want to do now is we want to turn those into the x values. So we set them each equal to 0. And we'll get x plus 3 equals 0. And we get x equal negative 3. So over here we got negative 3 is one of our places where it's going to cross over. We got x plus 3 equals 0, so x equals, x minus 3, so x equals positive 3, so we got one there. And then we have x minus 4 equals 0, and so we say x equal positive 4, and so that's there. So now when we go to graph this, we're again looking at the basic function of a cubic. And we know that the y-intercept is way up here at 36, so I want to attempt to go there. But in general, again, if I graph this, it would come up, go here, come down through 3, turn right here, and go back up through 4. And that is generally what our graph would look like. Now, of course, we can go in between, and we know that this would be at 36, and we could plot more points to be more accurate. However, in this case, we're just looking at what the sketch looks like in general. Okay, let's do another example. In this case, we have a x to the 4th. Let's bring this over here. We've got x to the 4th minus 6x cubed plus 11x squared minus 6x. Now, in many cases, what we want to do is we want to try and factor out a GCF. Remember, the rules of factoring are find the GCF. If it's a quadratic, factor it. If it's a is greater than 1, we try and factor that. Then after that, we might look for patterns, binomial squares, or a perfect trinomial, which is you can take the square root of the ends, and if that's a multiple of 2 in the middle, then you've got a perfect square binomial or a trinomial. In this case, we have an x that's in common. So what I'm going to do is I will factor out that x, and then I'll reduce the powers 6x squared plus 11x minus 6, right? And now we've got a cubic that is a little bit more manageable. So we always want to look to reduce to see if we can make it more manageable. And in doing so, we find through some synthetic division, if we tried synthetic division, this would be 1, negative 6, plus 11, minus 6. And if we try 1, of course, I've already done this so that we know what what it's going to look like. So we bring the 1 down, of course, if you remember. 1 times 1 is 1. That gives us negative 5. And then negative 5 times 1 is negative 5. Add that. 11 minus 5 is positive 6. 1 times 6 is 6, and we get the awesome news of having a 0 at the end, which means 1, x equal 1, is a factor, and we can put that right there to start drawing. Then we can factor this. We know that if we bring this, what two numbers multiply to 6 and add to negative 5? Well, if you try 1 and 6, you may not get too far, because whenever you multiply, you got to subtract. When you multiply it, it's got to be a positive, so that means we need two negative numbers. So I'm going to go with negative 2 and negative 3. And so those x's are at x equal 2 and x equal 3. So I'll come here and do that. And then we also have a 0, right? Remember the original one that we factored out, that's also there. So this one, again, the behavior of something to the fourth power, positive, looks like a w, right? So that's what it's going to look like. So we can then graph this function as if we know that it's going to go through. None of them have a multiplicity of 2. They're all multiplicity 1, so they're all going to go through. And again, we can try and figure out the depth of some of these, but in general, what this looks like is if it comes down through here, and then goes around, comes down, around, and then goes back up, that's what the graph will generally look like, right? Again, if we put numbers in between, we could find out how high and low that's going, but in essence, that's what the general graph looks like. Okay, one final example is graphing just by factors. So we don't have to factor this one. We've already got it done. And let's see if I can scoot this over so you can see a little bit better. There we go. We've got x plus 1 quantity squared. We've got x minus 3 quantity squared. And then x plus 4. So when we have those, that means that we're going to have zeros at x equal negative 1, x equal positive 3, and x equal negative 4. So we've got one. Let's fix this. That looks a little crazy. X equals 3. So we got x at negative 1. Okay, put a little star there. X at positive 3, all the way over there, and then at negative 4. Now let's see. This one is something to the fifth power. If we take 2 plus 2 plus 1, that's something to the fifth power. If you recall, something to the fifth power that's positive, 1, 2, 3, and then up, right? 1 turn, 2 turns, 3 turns, 4 turns, and then it goes up. So we know it's going to generally look like that. And so let's see, how would this graph out? Well, at x equal negative 1 and x equal 3, those are bouncers, right? That's going to bounce. So what this graph would then look like is if it comes up, right, and then it curves, and it's going to go down. And once it hits negative 1, it's going to go back up, right, and cross across the y-axis, go head back down towards 3, and then it's going to start making its way back up again to positive infinity. And that's what that graph in general would look like based on the zeros that we have. Okay, well, I hope this video has helped. Some general graphing polynomials from zeros with some different methods to factor to find the zeros. There's lots of different factoring videos out there that I've done and other people have done. So good luck with graphing polynomials. It can be fun and exciting. As long as you're working with the zeros and a y-intercept, it makes the process a whole lot easier. Thanks again for checking it out. Hope you have a great day, and we'll talk to you soon. D Dykstra out. Thanks.